Hi, and welcome to the next video. Today I would like to do something slightly different. I have this Android architecture samples project on GitHub, and I would like to go through it, see what it is it composed of, and I invite you to go on this journey together with me. This might be, if it works, the first episode of maybe more videos like this, simply because if you have a look here in different branches, we have different versions of this project. But also there is plenty of other projects on the web that we could try to review, we could try to see how they work and maybe learn something out of them. Then, let's begin. Let's look into the README of this project, and we have explained more or less what this branch, the main branch, is using. In this branch they are using for user interface Jetpack Compose. There is a single activity architecture using Navigation Compose. We have a presentation layer, also with Compose, and we have some view models. There is reactive UI with flow and coroutines. We have a data layer with a repository, with room. And also there are some flavors for mock and prod, maybe we will have a look into that also. For dependency injection we have Hilt, and we also have a bunch of tests. I think it's a very interesting mix, because it's a very modern stack for an Android application. It might be sometimes a problem, because at least I have a feeling that the Android community usually strives to get all the newest tech and so on integrated as soon as possible. So 4 years ago, if you would be starting a project, it would be probably a reactive project based on XMLs. There would be the new navigation for XMLs with XML as well and stuff like that. There would be room already, but no flows, no coroutines, no compose, no of course navigation compose, and there wasn't Hilt as well. You would just use either Dagger, or at that time there was also Coin that I think came into the picture and was starting to get a bit popular. There was Codeine as well. So just 4 years passed since that time and everything changed, and if you would look another 4 years back, then the picture would be again completely different. There was no RX, we would have loaders, probably people still used async task and stuff like this. So I think things are changing really fast in Android. In this project we definitely can learn a lot how we can architect the application, because after all it's an architecture samples using all the newest technologies that we have. So what is the application? It's just a simple tool application, as we can see on the screenshot over here. If we look into our Android Studio, I've already cloned this project and run it just so we can see over here in the emulator. This is the application. Let's try to add some task. We have a title to do what we can do, review and up, and we can probably add some description. Enter your task here. Yes, so this is a description. Let's add a new task. There we go, a nice task added with a snack bar. We can mark it as done, we can mark it as it's not done again. Then what else we have? We have some sorting, filtering options over here. And here we have also, we can clear, complete it. So probably if we complete it, then we can remove it this way. Yes. We create the completed tasks, and now we have some new tasks appeared. Let's try it again, let's complete them, clear. Oh, no task this time, no idea. Refresh. No tasks. Well, let's create a new task. Task A with description V. Why not? Let's add task B with description V. Now we have two tasks. If we don't have completed task, it doesn't clear anything, and we have some statistics which says active tasks and completed tasks over here. Let's see if that works. There we go, 50-50. Very good. Okay, that's the application. Now let's have a look into the project. What do we have here? Let's start with build Gradle. We have some build script, we have some versions, we use 1.7 Kotlin. I think right now there is 1.7.10. But I think it doesn't work with the newest Gradle plugin, so I had some problems recently. What else do we have? Minimum SDK version 21, so when the compat library started appearing and making our life really simpler. Target version 32, compile version 32, not the newest, but looks good. And then we have a whole bunch of versions defined over here in the ext. So we don't use like, for example, the Gradle catalog over here, we just have the versions defined in the build script. Let's have a look at this build Gradle. What do we have in the app? We have, of course, our compile version, build configuration, a very long application ID, and what else is here? Java compilations with incremental room. Then we have some source set. It's not too important. Build types, we minify. We don't minify in debug, of course. And then we of course do it and we shrink resources on release. Build flavor, build features, we use compose. We have Java 1.8 and a whole bunch of dependencies. For Android architecture, we have room with KTX. For Kotlin, we use Timber. What else is interesting over here? Of course, all the compose, lifecycle, navigation, dependencies, more compose. Here we have the testing, JUnit and stuff, Espresso, Robolectic even. More testing dependencies, also again, Espresso, because here we have the instrumentation tests. Okay, it doesn't look too bad. Let's have a look into Android manifest quickly also to just see what we have, and there's really not much over here. We don't even use internet for anything, so we don't have any permissions. We just have the application. We have some to-do applications, so we extend the application class. We have just standard theme and one activity, which is just the launcher activity. That's it. So as the GitHub README said that we use the architecture where there is only one activity and then we have everything in compose, so we shouldn't necessarily expect to have more than one activity over here. Our application does not much as well, so it sets the timber. Okay, so in the application on create we only set if we are in debug from our build config, which is generated, then we plan the debug tree. Nothing more happens here. And in the to-do activity, to-dos activity, again nothing really happens here. It's an Android entry point, so this is from Hilt. There we go. So currently we don't have also any dependencies injected over here, but that's coming for the dependency injection framework. And then we have just set content to start compose. We have some appcompat theme. Let's have a quick look into that. There we go. Where is it coming from? There. From appcompat theme dependency. So we don't define our own theme in this app, maybe not. We will see. And then also after we set the theme, which is the appcompat theme, we have this to-do nav graph. Now maybe let's have just the code over here. And that's our first composable function, and this composable function sets the navigation. So we have the nav host composable over here, which is like the top level navigation entry point, if we can call it this way, where we defined everything. We have these composables over here with some routes probably. Yes, so to the destination task route with some arguments, and then we have just our composable over here, and we do something like start the task screen. Okay, so our app is composed out of screens, or that's an arbitrary name of course, but composables probably which are postfixed with screen. They are like full page screens that we can navigate through. Let's see, we have statistic screens, so that will be probably this. And we also have add edit task screen, so if we go back, we tap on the fab, then this will be that. And task detail screen, then that's something I didn't see. If we click on, okay, there we go. If we click on the task, then we also have the detail screen, and we can also check it and uncheck over here and remove with this action in the up bar. Nice. So altogether we have 1, 2, 3, 4 screens, and yeah, they're defined here with the nav host. We should have the nav controller somewhere probably. There it is. Current nav backstack entry. Oh no, from the nav controller, yes. And the nav controller is here. So we define it in the constructor. And we just use the remember nav controller method to get it. Function, not method. Then we pass, of course, to the nav host the controller. So basically it's just the standard navigation that comes with Compose. For that we have this routes specified over here. And it works a little bit like in web. So we have an address, let's call it an address, which is this route. So each route is like an address, and by this address we can identify a screen to which we want to navigate, which feels very webby and some people don't really like it. There are, I think, some libraries, what they were called now. So for example, somewhere I've read recently about this library, Compose Destinations, which is like a different way to do the Compose navigation, where we don't have to specify these routes, and so it doesn't look so much as web, which we definitely don't need in Android. Like in Flutter, maybe it's a different story, because Flutter is built into different platforms and web. So for web, it is actually making a lot of sense to have navigation done with routes, so you can then just use them in the address fields of a browser. But I think here in Compose with Kotlin, where this is actually only used for Android, then maybe this is not the best solution. But anyways, so actually we can have a look. So this is to the destinations, and this is where we have all these routes defined apparently. Let's have a look. Yes, in this class. So it's an object, okay. And then it's composed from other constants which are defined somewhere above. For to-do screens we have one to-do's, destination arguments, and so on. Okay, so we just compose everything out of const, and we have then this final routes that we use. And also then this class here, to the navigation actions, it gets us an argument, the nav controller, and then it has function to navigate to different screens. So actually the whole navigation is done in this one class. I think if we would have an application that would be much larger than this, then this solution could potentially be a problem, because this to the navigation actions, that will just grow quite a lot. Let's say that we have 50 different screens, so with this approach we will have 50 different functions over here, which is not ideal. Maybe there would be a different solution so we can organize it somehow better. Okay, but what does a function like this does? We have the nav controller, we navigate, we have the route, we can apply some arguments over here to it, so like navigate to tasks, we can have a user message apparently, which is an integer, and we can pass it. But for example, if we go to the task detail screen, then we just pass the task ID, and it's just appended over here to the root for the task detail screen. So I assume then that we don't, in this case we just pass this simple string, which is an ID, and then we will just take the task on the detail screen out of a database probably and display, rather than passing the whole object of the to do here. Okay, let's go back here. There's nothing more that we have to look into. Then let's have a look at some of the screens maybe. Okay, so we have this add task, add edit task screen. Okay, so we are of course reusing, so it's more like save. I find this add edit name a little confusing, but yeah, now I know what it means. We could think that it's like a save screen, so if it's already an item that has an ID, then it's getting saved, otherwise it's getting created when we tap on some button. So this is one feature then that we have, kind of like it's a part of feature, because actually we have only one feature in this app, which is the tasks, the to-do tasks. Okay, then there is task screen over here. We have statistics here and task details over here. Then let's have a look what we have. Let's start with the task screen maybe. Task details, task model, task screen. Okay, here we have some license information on top. That's not important for us. Then we have a composable here for the task screen, and it takes a whole lot of arguments. Some user message, then we have an on-add task. So there is some state hosting probably happening over here, where we can assign all of these callbacks for whatever happens, like on task screen. So actually the navigation would then be lifted up from the screen maybe. Let's have a look later into that. We start building scaffold, and as far as I know, this experimental lifecycle component API might be for this scaffold over here. Then we have some scaffold state, which comes from here, which is just remember scaffold state. So we use this function provided to us. There we go, it just takes care of the drawer and it takes care of the snack bar. Then we have the top bar defined, so let's go back to the tasks list. There we go, so we have this top bar on top, which has this button to open drawer. We have some title and some action buttons on the right over here. We are using some tasks top bar, so I believe that is defined by the project. There we go. It's a composable. Again, it gets all of these callbacks as arguments, and then we have here the top up bar, which is coming from the SDK. There we go. I believe this is the newer SDK then, because I think before we had like a couple of different top up bars. There was a small, medium and large, I think. And now I believe there will be only one, but I'm not 100% sure over here. Yes, we have the top and we have the bottom available. Anyways, we set the title over here, which is just a resource. All good R, which is generated for us out of the strings, and then we have the app name, nothing fancy here. Then we have the navigation icon, and this navigation icon is used to open the drawer, because this usually what this is used for is the back button, but of course on the first screen we don't necessarily want to have a back button. Depends on the UI, of course. There are cases where this would make sense. And then we have these two actions defined over here, and we have just a modifier to fill the whole screen with compose. And all of the actions are also defined as separate composable. So we have the drop down menu, because this is a top up bar drop down. Yep. So if we open the filter functionality, then we have this drop down, so it's just defined over here. And then for the more tasks menu, again we have another drop down. I have broken something. There we go. And it looks like, okay, so this file is called top up bars. It actually takes care of all top bars over here for all of the screens. Again, I'm not sure whether this is the best solution ever, for the simple reason that the more screens you have, the more composable functions and previews you have to keep in this one file. But for a simple project like this, just to showcase, I think it's okay. Let's see where it sits. It's here in utils. So in utils we have top up bar, topuppbars.kt. Well, if this top up bars would be somehow reusable, so there would be not one per screen like statistics, then we could have like shared composables directory maybe and keep them in there. But in this case, I would keep them in separate directories where the screens are over here. Okay, but let's go back to our screen, to the task screen. We have some filter type over here, which is just an enum. So that's for this. And we have a view model. Okay, so our screen, we were here at the top up bar. Again, a modifier, we just fill max size, possible max size, so both height and width. And we add this floating action button here. So that's this thing gets an icon, nothing fancy happening here. And finally, in the body of scaffold, what do we have here? So we have UI state, which is collect as state with lifecycle. So we probably use flow here. And a view model. Okay, so the view model has UI state, and then we render the state. In other words, we can think this is nice with the declarative frameworks, because instead of having the state just everywhere access or propagated, or when we have binding, it's just all interconnected together. In this case, we can think of UI as it's a function of state. So we have some state, and every time the state changes, then we can re-render our whole UI, or a part of UI that needs to be re-rendered. So inside we have the tasks content, which gets again lots of arguments with all the callbacks. Okay, so all the callbacks are actually set here, like on refresh, on task click. Okay, we all pass to this tasks content composable, which is defined down here. And besides of that, we have this UI state, user message. Okay, so whenever something happens, like here we have the snack bar, then we have to launch, of course, the launch effect, because it has to do something in the UI outside of the normal composition or recomposition. I maybe will make a video about the launch effects, or generally site effects. There are a couple of these effects available. And here we also have remember updated state, on user state message displayed. And then we have also another launch effect on the user message. Okay. And here is just this tasks content. So this list over here rendered, and for that we have a column. Inside of that we have some text for all tasks, and then we have a lazy column. And this lazy column then finally renders are the list. So I believe we would, okay, now I refresh it, but if we would have more text, then we can scroll it thanks to this lazy column over here. And finally here we have a single task item as well as a composable. Then we have some empty content, right, because if we remove them all, this is something people tend to, I don't want to refresh, I want to clear completed, yes. Frequently forget to implement is some empty screen. So if there are no tasks, then we don't want to just have a list with no items displayed, but we want to have some screen instead, and that's what is implemented over here. And then we have previous, we can skip the previous. To summarize, we have this composable task screen as we went through it a little bit. And from that point, this point of, so it's like the view layer in the architecture. And from here we are going basically to a view model. Therefore, let's go to view model. And here is our view model. We have the data class defined over here for state. In case you don't know why data class is here, it's because it basically comes with a couple of handy methods like copy with. And I think in terms of state, it's super handy to have this copy with method. Dart, for example, does not have meta programming, and because of that we don't have there any data classes. Instead, what we do is we have a library which uses code generation to make this kind of stuff work. But actually meta programming is coming in future. There is an issue for a long time, but as far as I know, the Dart team is working on it, so maybe things will get better, and maybe we'll get our own version of data classes in Dart as well soon. Anyways, that was a small digression. Our state, UI state, it has some items, it has whether it's loading currently, so because then we have to show this little spinner over here. We also have the filters, filtering state, and some user message, probably for the snack bar. And here is the viewModel itself. Of course, we inject dependencies with Hilt. So we have it annotated with the Hilt viewModel. This is generally super handy because we don't have to mess anymore with all these factories, creation factories, and so on. For viewModels, makes everything a lot simpler. And then we are passing here directly a repository. So if we are passing directly a repository here, then we have to think of viewModel also a little bit like it would be the domain layer. So the domain logic would also happen here then in the viewModel. Usually when we think about in-layered architecture or more closely in the clean architecture, then we have clearly distinct layer for domain, and then we have some interactors in it or use cases and entities. And actually if we go just here to the repository, then there is also branch, I believe. There we go, a branch called use cases where they also showcase how to do it. I think with experience of many developers, it came just to the realization maybe that use cases are not necessary, this domain layer not necessarily needed. I think in the mobile apps at least. I don't necessarily agree 100% with it. I prefer to have domain logic encapsulated within use cases. We have some tasks repository over here, and we have some saved state handle over here. So in the viewModel, what does happen here? We have some state flow for our state. So UI state is a state flow, and it is combining all of these things in here. So we have the mutable state for user message, also for this loading and the filters and everything. And then this is combining all of it into a single state. Okay, so if the tasks are being loaded, so this async tasks async is loading, then we are of course setting UI state with is loading, and otherwise if we have tasks, then we are loading everything else. So because of course we cannot filter, for example, if we don't have the tasks yet. And then we just at the end define that this happens in the viewModel scope, and it should be started while the UI is subscribed, and finally the initial value is the task UI state with is loading to true. So of course at the beginning we need to start loading the tasks. And then we have a couple of methods over here to do different things. The whole architecture works here with coroutines, and since we are in viewModel, then we are using the viewModel scope. We are launching other coroutines, and then, for example, over here on the clear completed task, we have the repository directly called. Let's have a look. So the repository is actually an interface. Let's also locate it. We have a directory here for data. For the data layer in our architecture, and inside of this we have sources, and here is a default task. Okay, so this is task repository, and then it's probably implemented in the default tasks repository. So here we have a suspend function for the clear completed tasks, and we have a coroutine scope inside of which we launch two things. So first we launch to clear completed tasks on tasks remote data source, and then on local. So in this architecture we have two different sources. As far as I remember from the README, then the remote data source actually faked or mocked here. Tasks remote. Yeah, there is actually no any connection to internet in this project, so this is all fake. Maybe that's where the initial values appeared once. Yes, there it is, exactly. So at the beginning when I was playing around with the app, you could see that these two values just appeared out of nowhere. So this was actually a simulated request to a network happening, and at some point it finished, and that's where we got these two tasks that I definitely did not. From the UI we have our compose elements, then compose elements have state that is coming from the view model, which is the standard Android architecture component view model. Then this view model is talking to repositories. Repositories have interfaces, and these interfaces are implemented, and finally this implemented interfaces, like this one we have open right now, it has dependencies to local and remote data sources, which finally work on data. So the remote data source, it doesn't actually work on any remote endpoint or any API right now, it's just mocked, but we can have a look. We've seen already in the dependencies that the local data source, yes, so it's basically Room implementation with Flow, so Room already knows about Flow. All these components from Jetpack are basically interconnected, so Room is able to give us different kinds of data and different structure, and in this case we are using Flow all over this application. And here we have a typical Room interface for data access object with queries, with beautiful SQL, where we can get tasks, we can observe task by ID, so in case of any changes then we will get notified through this flow. So if you subscribe to that flow, then we will get all the information. We have some insert update, so basically every single of the CRUD operations, so create, update, read, delete, is implemented over here for us. Let's have a look quickly into how is DI also may be done in this project. We have two modules. One module has just a quantifier here defined for I/O dispatchers, and we have a module, coroutines module, which is then installed in a singleton component. It's all coming from Hilt, and with this we can just inject the dispatchers on I/O, so we can then run something on I/O. And then we have the data module, and I believe this will be for the repositories, data sources, and so on, and there we go. So in data modules we have this repository module over here, and this takes care of the task repository, which returns the default task repository. We have only this one, and we are injecting to it, of course, the data sources, the I/O dispatcher. And here we have the modules for database and the data sources themselves. So task remote data source, and here is for the local data source, which needs the database from here. And it also needs a dispatcher, so a coroutine dispatcher here. So we will run it on the I/O. We can see that here is the quantifier, and that was defined over here for this specific dispatcher. Do we have anything else that is worth looking at in this project? Not necessarily. It's actually fairly simple, so I've already outlined it in a moment ago, but one more time to summarize. We have basically the presentation layer, which is kind of combined with domain layer, and then this is talking to the view through UI state that is defined as flow. And aside of that, we have the data layer where we have typical repositories, even with the interface, which is nice. And we have the data sources where we actually interact with some outside world with the I/O, with remote and local databases, APIs, stuff like that. To finally summarize it all in all, like if I would be coming to a project, an Android project 4 years ago, as I said, we would definitely see different technologies. We would see the RxJava, we would have XMLs, we would have the navigation through the navigation graphs. There are also elements that would be there, like Room, that were already existed, view models, they were already there, and we probably would use live data instead of the flow and flow state, things like that. The architecture itself, it didn't change. We still have layers. In this case, we don't have the domain layer, but that was the case with Android for most of the time, because as far as I remember, when Google finally acknowledged that it's a good idea to promote some kind of an architecture where they went for the view model approach. They actually from the very beginning promoted the approach of having repositories access direct in view models. So they didn't really acknowledge that we need the use cases. And it's interesting to see that this approach didn't change, so we don't go into like the full-blown clean architecture approach, which comes with a lot of extra also additions with all the mappers and stuff, which are beneficial maybe for huge projects, for huge systems where changing dependencies would be costly otherwise. The good thing is, looking at this project, if you have been doing Android for some time, the concepts didn't change. So you will be easily able to work with a project using all this fancy new stuff like Compose. I think this is where I will stop for now. I'm sorry that this video is kind of maybe unprepared, because it's not prepared in any way. It's just me looking into some repository that I found online and reviewing what I see, more or less. And we will see. I will try maybe to do more of this. Maybe, as I mentioned, I will have a look into different versions of this project, but there is also a ton of other projects that I potentially would like to have a look into and maybe learn something, or maybe learn together with you. If you have any ideas, then please let me know in the comments. If you liked it, even though it was such improvised kind of way in this video, then still please give me a like and just make any kind of notification. So maybe I will create more of these very boring shows, as they like to call them, Flutter boring shows. Yep. Bye bye.